Hello happy students. Today our topic is Python Pandas data frame, and this is Python Pandas data frame part 9. In this lecture we are going to discuss about sorting and mean absolute deviation. So these topic will be discussed in this lecture. First one is sorting. So what is sorting? Sorting basically refers to arranging values in a particular order. The values can be sorted on the basis of a specified column or columns and can be ascending or descending order. And pandas make available sort values function for this purpose, which can be used as per following syntax. So that is the syntax of sorting. First, take the name of data frame. That is name of data frame first, and then function name. This is function name, and then by axis ascending true, in place false, kind, and a position. So that are the parameters which are passed in this function. So basically we can say that sorting is a technique to arrange data either in ascending order or in descending order, or we can sort a data in a data frame use row wise or column wise, and that is the syntax of the sorting. And the function used for sorting is sort underscore values. So this is the function used. Now the parameters. So what are the different parameters used for sort value? First one is by. It is a string or a list of string, name or a list or name to sort by, and by default axis is 0. So if axis is 0 or index, then by may contain index level and or column level, and if axis is 1 or column, then by may contain column level or index level. And the second one is axis, by default it is 0 as I told you earlier. Then ascending, bool or list of bool default is 2. It means by default ascending um, data is in ascending order when we sort a value, sort a column or sort a row, and by default its value is true. If we make them false, then data will be sort in descending order. Next is in place. So in place it is a bool or default false. If true performs operations in place, then any position, first class, default class, first plus puts any, and n refers for not a number at the beginning, and last puts n at the end. So these are the basic parameters used in sort underscore values. So now let us understand using an example here. So there is an example, and suppose the data frame name is df1, and when we apply a function sort underscore values and pass, and there is an argument of parameter pass within sort underscore values function, and that is a country. Basically country is a column name. So actually data will be sort according to name of column country and in ascending order, because by default it is in ascending order. So as we see that name of country first start from Brazil, then name Japan, and then UK, because Brazil, Japan, and USA, UK and USA. Brazil comes first because it starts with capital letter B and then J and then U and then after USA. And in this case UK and USA both are start with U, but UK comes first because second letter in this case is K, while USA second letter is S. So K comes first, that's why UK comes first and USA after, then UK. So this is a data frame df1 which is sorted according to country name, according to a column name country. So when we pass overall, we can conclude this as whenever we pass column name within short underscore values function, which works is to sort the data frame, then data frame will be sorted according to that column name. So now I think it is clear to all of you. Next is we again sort the values, but now sort this data frame according to column name tutor. So again, according to column name tutor, data will be sorted, but here data will be sorted in ascending order like in previous one. So in tutor, Anusha come first, and then Gurjot, and then Jacob, and then Tahira, and then Venkat. And why um, this order here? Because Anusha start with the letter A, Gurjot with G, Jacob with J, Tahira with T, and Venkat with B. So already there is ascending order, and data will be sorted according to that. So according to tutor, data will be sorted. Now there is one more question here, that when there are more than data according to short values. Now here tutor, there are four values with respect to Anusha. So what comes first? Which row? Which comes first? Which data with Anusha comes first? Whether it is 241 Japan 1 Anusha, or whether it is 1736 Brazil 4 Anusha. So the answer is that when the data um, we sort the data according to a column name, and column name have same value, then data will be sorted according to the manner in which data comes first. So which data comes first in original data will be appear here. So that is another example here. So in original data, when there are four datas, so first data appears first. That's why here first appears look like 241 Japan 1 Anusha. Next is next is what happens when we want to sort the data according to two columns names. Now here there are two columns name, country and tutor. So first of all, what happens that data will be sorted according to column name country, and when there are two values same when column name contains same country name, then data will be sorted according to tutor name. So we can easily see that. So when data is sorted according to country name, then the first country name which will be appear on the screen is Brazil, and then after Brazil contain actually four rows. Brazil appear four times in column name country. So the data is sorted again according to column name tutor, because Brazil has four values. In Brazil there are three values, Jacob, Tahir and Venkat. So now data will be sorted according to tutor name, and so first of all Jacob will be appear on the screen, and then after Tahira, and then after Venkat. So that is the order. If there is again a repetition of data, then data will be sorted according to what comes first in your original data frame. So that is another example. Now this is a second example. Here in this example, actually data is sorted according to tutor and country. So first of all, the first column name is tutor and second column name is country. So when we want to sort the data, then data will be sorted according to tutor name and then after country name, and that is similar to that of previous one, but the difference between these are In first case, data will be sorted according to country and tutor, and the second case, order is just reversed. First preference is for tutor column name, and second is for country. So we can say that value in first case value sorted country wise and within country tutor wise, and for second case value sorted tutor wise and within tutor and country wise. So there is a small example. Now there is another case. In this case we actually pass another parameter which is ascending, and when as I told you earlier, then there are many number of parameters passed within short values, and here we will discuss only the important parameters, and rest are not discussed because it is out of the scope of your syllabus. So that's why we discuss only the important aspects of the short values function. So second parameter which will be which we can be used is ascending. Basically has default value false. It means by default data will be short in ascending order, and when we take ascending is equal to false, then data will be short according to data will be short in descending order. So here ascending, we take value ascending is equal to false, so we can easily see that the result is just reverse as that of previous one, because in previous one data is sorted according to column name tutor and country, but ascending is true. In this case data is sorted according to tutor and country, but the difference between this and previous one is that the data is sorted in descending order, because ascending is equal to false here. So that's why we can easily see that Venkat comes first, then Tahira, then Jacob, then Gurjot, and then Anusha. So this is another example. Now there is an important point, and we can see that we are not giving the complete full syntax of the functions in this chapter, because we are only giving the syntax of the basic and minimal functioning. Discussing full syntax of this function is beyond the scope and the nature of the books. Actually it is the content of Sumita Arora IP. So as far as syllabus is concerned, it is full syntax is not part of your syllabus. That's why we explain here only a limited part which will be asked in your final examination. Next is so that is all about sorting. So basic important thing is we can sort the data using the function sort underscore values, and we can pass basically two arguments. First one is column name and second one is ascending is equal to true or false. So by default there is a ascending in data, and there is a data is in ascending order, and if we give the ascending is equal to false, then data will be short in descending order. So these are the important parts here, and one more thing is that when we discuss the syntax here, then any position is another parameter, and by default if the data frame contain any and values, then any and values we can change the order of any and values. If we put any position is equal to first, or any position is equal to last. If we put any position is equal to first, then any position any and values comes first, and if we put any and positions last, then any and values comes at the last in data frames. So this is another, and second one is in place. Second one is in place. So basically in place function or any positions are not very important parameters, but here because these are given, so that's why they are discussed here. And in place in any positions default is last. So for any position is concerned, if you don't pass any values regarding any positions, the default is passed. And if we put first puts any n at the beginning and last puts any n at the end, so there are two values regarding to any position. These are first and the last. And second is in place. It is a bool value, and by default it is false. And if it is true, it performs operation in place. So if you want to change a value, we can use in place parameters. Actually we can use in place parameter in place if you want to store the stored data in a data frame itself in place. So if we want to change the data after sorting, then we can use in place parameters. So after sorting we want to change the database order, then we can use in place parameter. And second one is second function here is MAD function. Actually it refers for mean absolute deviation, and in short write as mad. So mad function refers for mean absolute deviation. So first of all, let us see what is mean standard deviation. Mean standard deviation is a function is used to calculate the mean absolute deviation of the values for the required axis. And the mean absolute deviation of a set of data is the average distance between each data value and the mean. And to calculate mean standard deviation, we use mad function as per the following syntax. So first of all, name of data frame, after that mad function, and then after name of axis and skipna is equal to none. So there are basically two parameters here. Axis, by default axis is 0, and skipna basically is a boolean value, default is true. It means exclude any or null value. So when we use skipna as a true, then it exclude null values. If an entire row column any, the result will be any. So there are only two parameters for mad function. And there is a small example here. This is a data frame, and here first of all, to calculate mean standard deviation, there should be at least a data frame on which we can calculate mean standard deviation, mean absolute deviation. So there is a data frame named SAL_DF, in which there are four columns named 2016, 17, 18 and 19, and there are four rows, QTR1, QTR2, QTR3 and QTR4. This is the original data frame. Now if we want to calculate mean standard deviation, as I told you that mean standard deviation is nothing but it is a set of data uh, and the average distance between each data value and the mean. So first of all, this is the original data frame, and this is a mad function. Mean is mean absolute deviation according along axis 0 and along axis 1. It means column wise and row wise here. So this is the final output and how it is calculated. First of all, uh, let us consider case number 1. So along different year there are 4 years, 2016, 2017, 2018 and 2019, and there are four values given along these columns. So when we calculate mean absolute deviation, so we can calculate easily mean absolute deviation along axis 0. So when we calculate along axis 0, so there are four values there are four values, for one for 2016, another for 2017, and then for 2018 and 2019. So along 2016 we can easily see that there are four values: 34,500, 56,000, 47,000 and 49,000. So to calculate mean absolute deviation, first of all, what we have to calculate? We have to calculate mean first. So take the sum of all these four values. When we want to calculate mean absolute deviation along axis 0, and here we calculate value mean standard deviation, mean absolute deviation for 2016 only. So the sum of four values, 34,500 and 56,400, 56,000 and 47,000 and 49,000, is 1,86,500. And to calculate mean, there are, since four values, that's why we divide it by 4, and finally we get a number, and this number is 46625, 46,625. That is the mean. And after calculating the mean, we can easily calculate mean absolute deviation. To calculate mean absolute deviation, first of all, mean is to be calculated. Mean is 46,625. Here the word absolute. So what is the meaning of absolute? Absolute means we take only the positive value as far as difference is concerned. So we take the difference between mean and first one. This is 46,625 minus 34,500, and for second we take the difference 56,000 minus 400, 46,625. Here 56,000 comes first and 46,625 comes later. It is because we want to calculate only positive value here. So because absolute term is there, and absolute means only positive value will be concerned. So when we take the difference between values and mean, then we take only the positive value. And third value for 47,000 minus 46,625, and fourth value is 49,000 minus 46,625, and then we can divide it by 4. The answer is 6062.5. It means 6,062.5, and we can easily see that this is the value mean standard deviation for the 6,062.5. And in this way we can easily find out the mean absolute deviation for 2017, 2018, 2019, etc. This is a representation of the float 60 data type. Data type here is float 64. That's why it is appear here. So that is the mean absolute deviation along axis 0, and when we calculate it along axis 0, it means column wise mean absolute deviation will be calculated. And the mean absolute deviation for 2016 is 6,062.5, for 2017 it is 6,250, for 2018 it is 2,500, for 2019 it is 0.0, and data type is float 64. And why it is 0 for 2019? Because most of the values are NaN, and NaN refers for not a number. So mean is there is only a single value, and when we want to take mean, the mean is again that value, that is 61,000, and when we want to take the difference, then 61,000 minus 61,000 is equal to 0. That's why 0 appears here. And for column we can easily calculate this along column also. So this is along column QTR1, QTR2, QTR3, QTR4, and for QTR1 along column along axis 1 means row wise. So row wise standard deviation for QTR1 is 9025.0, QTR2 is 3311.1, for QTR3 it is 4444, and QTR4 it is 4333.33, and data type is float 64, it is default. Last is standard deviation, because here we discussed mean absolute deviation. So there is another question raised in our mind, that what is the difference between mean absolute deviation and standard deviation. So basically standard deviation, I already discussed standard deviation in previous lecture, but here I give some important points regarding standard deviation. Actually, standard deviation measures the how spread out numbers are, and it is represented by Greek letter sigma. And as far as its calculation is concerned, it is the square root of the variance. So if you want to calculate a standard deviation, first of all you want to calculate uh, you should calculate variance first. After that only you can calculate standard deviation. Now another question, what is the variance? So the variance is the average of the square difference from the mean. So first of all, if you want to calculate the variance, then mean should be calculated, and after calculation of mean, subtract the mean and square the result, and then work the average for those square differences. So let us take an example. Here is a small example. You and your friends have just measured the height of your dogs in millimeter. There are different breeds of dog here, 5 breeds of dogs here, and measured the heights of dogs in terms of in millimeters. So height at the shoulders are 600 millimeter, 470 millimeter, 170 millimeter, 430 millimeter, and 430 millimeter and 300 millimeter. So find out the mean, the variance, and the standard deviation. So first task is to calculate mean. So to calculate mean, so taking the sum of four values, and the sum of four values are 600, 470, 470, 170, 430 plus 300, and since the total number of values are 5, so we divide sum by 5. So final answer is 1970 divided by 5. So that is the mean. So the mean is actually 394 millimeter. So 394 millimeter is the mean, and after calculating the mean we can easily find the variance, and variance is represented by sigma square, and variance is nothing but only the difference, take the difference between values and mean and then square it. So using this we can easily find the variance, and variance in this case are 21,704. And to calculate standard deviation, just under root the variance, and variance is 21,704. That's why we take the under root of 21,704, and final answer is 1,147. So 147 is the standard deviation. So this is all about the calculation of standard deviation. So what is the purpose of calculating standard deviation? So in this case, one thing good about the standard deviation is that it is useful, and it show the which heights are within standard deviations. Standard deviation are 147, so we can check height of different dogs and compare it with the standard deviation 147 millimeter. So using the standard deviation, we have a standard way of knowing what is normal and what is extra large or extra small. So that is the basic purpose of calculate calculate standard deviation. Now in Python pandas data frame, there is a data frame here, and to calculate standard deviation we use the function stt. Again, standard deviation can be calculated along axis 0 and along axis 1. So there is a same data frame, used for mean absolute deviation. And here, when we want to calculate standard deviation, just write name of data frame. Name of data frame is sal underscore df, and after that dot sign, and after that std is a function which calculate standard deviation, and by default it calculates standard deviation along axis. That's why no parameter is passed within std, and there are different standard deviations along different years: 2016, 2017, 2018 and 2019. Remember that when we calculate standard deviation or mean absolute deviation along axis 0, it means we take standard deviation or mean absolute deviation column wise, and for axis 1 it is row wise. So for calculate standard deviation along row wise, along row, we can pass the parameter x is equal to 1. So q2 standard deviation along axis 1 will be calculated after the execution of that statement. It means for q2r1, q2r2, q2r3 and q2r4. And last, there is a mention of data type, the float 64, which is a default data type. I hope you like this video. So first of all, um, do this numericals manually, and after that on practice over these functions on your computer. So that is the final slide. Goodbye.